This is a recap of Monday, October 5th. Today we went through a Pear Deck presentation and we discussed adding and subtracting fractions. And we had some examples, which I'll do. And then after the examples, then students went to the link that you'll find in today's agenda and put question marks or checks by each of the cards to indicate whether they understood it. So the first thing we talked about was when we add fractions that have different denominators, we're really talking about different sizes. So looking at the size of this green section, it is different than the size of that green section. So those are different sizes, so we have to do something in order to add. It would be like if we tried to add those two, it would be like adding a dime plus a quarter and saying that you have two of any particular thing, which you couldn't say. You have to switch it to pennies or switch it to nickels. So first, we actually started with adding or subtracting fractions that have the same size. So one thing we pointed out here was that this box right here, this one square, is the same size as this square. So if the whole is split into pieces that are the same size, then they can be simply added. You can just count them up. So I have 1 here, 2, 3. And if I add them all together, there they are right there. So that's where we get 3/5. So this is how many? And this is the size. So it'd be like saying that I have 3 nickels. So that is the size right there. And so we wrote in our notes that to add or subtract fractions, you want to have a common denominator or a common size. So that's what denominator is. The denominator, again, is the size of the part, the fraction. So if it's a half or a third or a fourth or whatever the denominator is, it determines the size. And what's interesting is the bigger the number on the denominator, the smaller the piece. So compare a 2 with a 10. That size is much bigger Let's see if I can split this into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You get the idea. That one of those is much smaller than one of those. Even though the denominator number is smaller, it cuts it into fewer pieces, making the pieces bigger. And this was an example that you can put into your notes about how to add or subtract fractions that have the same size denominator. Whoops, let me go back there. So just something to notice that this stays the same and this 12 stays the same. So this is how many dimes. You have a dime, you have 7 dimes, you have 8 dimes. You have 7/12 of something and you take away 3/12. In fact, here's what we did in class. We drew a picture of this 12ths. So let's take one whole something and we'll cut it into 12 equal parts. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We'll pretend that those are all the same exact size, and we'll shade in 7 of them. 1, 2, 3, 4, 5, 6, 7 of those parts. And then we're going to, so that's 7/12. Write that when I get a chance. All right. So that is 7/12. And now I'm going to subtract away 3 of those 12s by just going to the eraser tool. There's 1, 2, 3. So I just subtracted 3 of those. The empty spot is still there, but now we have 4 out of 12. Minus 3 of those 12s is 4 12s. And if we want to see how that simplifies to 1/3, we can see it this way. We could put this into one group of 4 and make 2 more groups of 4. And really, let me get the eraser back out and just erase these division lines. There we go. Just erase those in the middle, erase those. Erase those lines and then reshade it. And that's really a picture of simplification. The shaded amount stayed the same, but how we viewed the picture was simplified into 1/3. By watching these recaps, sometimes you get a little extra information because that wasn't even discussed, or that picture was, we did it, but that was a better picture than we did in class. Okay, here's the main message from class. What do we do when the sizes are different? So here is what we did. Last week we talked about the least common multiple. We need to find a denominator that can work for both fifths and halves, and it doesn't look real obvious from the picture. So we're going to find the least common multiple of 2 and 5. So just multiples of 2 and multiples of 5. And I just have to stop right there because I've already found one that goes into, or a multiple that's in both lists. And it's the first one that came up. So we're going to change 2/5 times something is equal to 10. Multiply it by that same thing to see how many tenths we have. So 5 times 2 is 10. So we have to multiply by that same 2. We get 4 tenths. 2 times something is going to equal 10. So that's 5. So I multiply the 1 times 5. 1 times 5 is 5. So we have now 4 tenths plus 5 tenths, and that's equal to 9 tenths. So if we were to add these together, we would get 9 tenths. But we have to find a common denominator to do that. We've used the least common multiple of their denominators. And there's a picture of what that looked like. What I like about the picture is that it turns them both green, showing the same size right here. So this is green because it's the same as that size right there. And then we wrote to add or subtract fractions, we have to find a common denominator and then add or subtract the fractions and simplify if you need to. And we discussed that denominator is the same as size. And then we tried an example, 1/6 plus 2/9. If I put the multiples of 6 and 9 next to each other, I don't have to go too far before I find one that's in both lists. It's 18. It's the first one that's in both of the lists. So I'm going to change 1/6. Something times 6 is equal to 18. We'll multiply by that same multiplier to get our numerator, 6 times 3. So that's 3/18. Do the same thing for 2/9. 9 times something is equal to 18. 9 times 2. So we're going to do 2 times 2, that's 4/18. So we'll add 3/18 plus 4/18. And the answer is going to be in 18ths because that's the size. And we're going to add just 3 plus the 4 to get 7. So 7/18 is the answer on that one. We didn't do the next one in class, but we can do it real quick right here since we have time. I'm going to list the multiples of 4 and 10, not 4/10, but 4 and 10, 4, 8, 12, 16, 20. Multiples of 10 are 10 and 20, 30. We keep going, but we found one. So 9/10 is just doubles to 18/20. And 3/4. We multiply by 5 to get 20ths. So we have to multiply this by 5, we get 15. So we're going to do 18/20 minus 15/20 to get 3/20. I wonder if we can simplify that. And to do that, we would list the factors of 3, which is just 1 and 3. We'd list the factors of 20, which are 1, 2, 4, 5, 10, and 20. There's nothing in common, so this cannot be simplified. So that is as simple of an answer as we can get. It is a simplified answer. And then there is a video that some people watch. It's optional, but if you want more examples, then you can click on that. To get there, I'm not going to play it in this video, but you could go to the link in today's agenda, and it's going to take you to this presentation, which I'd like you to go to anyway if you haven't done it. And at the end, there is a link on the last card that will take you right to this video. It's a very good video, and I encourage you to watch it and get some more examples. There was work time today in class, and then towards the end of the period, we all came back and we took a look at classwork. And I want to point out a couple of things. I made some announcements. We went back to last week and we went through and talked about some of these. And here's a couple of announcements. If you haven't done F5 yet, you can still do F5. If you haven't done any of these yet, you can still do them. You will still get credit. Your grade will be updated. The answers to these two assignments were in last Thursday's recap. I'll go back to that in a moment. You get all the credit for doing this quiz, even if you miss problems. Eventually, we will have quizzes where you have to get all the answers right to get all the points, but right now they're participation. Speaking of participation, today you're going to get a score based on your participation from last week. So I'll look at last week, look at your participation through coming to class, asking questions, doing assignments, and you'll probably get a 5 out of 5. And we have a quiz that you can do now. It is due tomorrow. We have another IXL, another CAMI that we'll work on together, and another Desmos. We will be working on these together this week. I want you to notice a pattern that there's a quiz at the beginning of the week. We don't have any more join classes, but look at the IXL on Wednesdays, look at the CAMI on Thursdays, look at the Desmos on Fridays. That pattern is going to continue. Okay, last thing. If you need help and you want to come to office hours, here's where you find them. You go to Math 7 Resources, and at 2 o'clock or at 8 o'clock, you click right here and there'll be a meeting and I will be there and I can help you. Okay, that is a recap.